I'm Anil Kumar. Welcome to my series on providing you with solutions of international test papers. Here is an excellent question from the Cambridge International Examination 2018 June. So this is advanced mathematics, and we'll discuss a question which deals with finding area between the curves. So it has a lot of components in it. We'll see how to answer this type of question. So the question here is, figure 2 shows a sketch of part of the curve C with the equation y equals to x ln x, where x is greater than 0. The line L is normal to C at point P, EE. The region R, shown shaded in figure 2, is bounded by the curve C, the line L, and the x-axis. Show that the exact area of R is a square plus b, where a and b are rational numbers to be found. Very good question. So I'd like you to go through this, try to understand how do we find the area of this shaded region R. Now to begin with, what we are given here is that this line is perpendicular, right? Normal. So we know this is perpendicular. So the idea is to find the equation of this line, and we need to find this point also, which is the x-intercept, right? In fact, we need to find this point also, the where the curve cuts the x-axis. So our area will be now defined by these 3 points. So let's begin by finding the equation of this line, then the x-intercepts, and then we'll find the area under the curve. Perfect. So what I'll do here, since there's less space on this page, we'll take it on a fresh page to find the area, rather the equation of the line. So I've copied this part of the question here, which is find the equation of line normal to the curve y equals to x ln x, right? That was the equation given to us, right? At the point P, EE. So that's what it is. So we are given the curve which is y equals to x ln x, right? We know that x is greater than 0. Now dy dx, which is the derivative, will be, we can do product rule. So 1 times ln x plus x times derivative of ln x, which is 1 over x, correct? So dy dx is basically equal to ln x plus 1. Now we need to find this slope at x equals to e, right? So we have dy dx at x equals to e as ln e plus 1. Now ln e is 1, so we get this as 1 plus 1, which is 2. So that is the slope at that point for the curve, right? So what we really found was, let's reconstruct our graph here. Okay, let's do it here. So I'm just making a rough sketch for the graph, which looks kind of like this. So we found equation of the tangent line. Let me just draw a tangent line. So this is the curve C. So at this point, we got the tangent, right? So slope of this is basically 2. So what should be the slope of the tangent? Normal. Normal will be negative reciprocal, correct? So we want to find this slope, m, right, of the normal. So what should that be? So slope of the normal line, so that perpendicular line, will be negative half, correct? So we know the slope of this line. Now let's find the equation of this line. So we have a point here P, which is EE, correct? So we have a point P, which is EE, and we have the slope, which is minus half. So from here, we can write down the equation of the line. So let's say line is L. So the equation of the line will be, we can write this as y minus y value equals to slope x minus e, right? So that is how we could get the equation. Just multiply by 2. So we get 2y minus 2e equals to minus x plus e. Bringing them together, we get x plus 2y. We'll keep these constants on the right side, we'll find the x-intercept. So that gives us 3e, right? Okay, so that becomes our equation of the line. Now let us extend and find the x-intercept. Let's find the x-intercept of this line of L, correct? So at x-intercept, y value is 0, that is to say y equals to 0, correct? So substituting y equals to 0, we get x equals to 3e, right? So this point is 3e. All right, okay. Let's also define and find this particular point also, and so we'll find the x-intercept for curve. Curve C, right, which is given by the equation y equals to x ln x, right? So if I substitute 0 for y here, I got 0 equals to x ln x. So that gives me two values, and that is we have x equals to 0 and we have x equals to 1, correct? So these are the two values. So this point here is 1, correct? And that is 0. Is that clear to you? So in a way, we got a triangle. Now, let us see how to find area of this particular triangle. That means we are interested in this area, correct? Okay, so let's get back to our question and then we'll continue from here. Okay, so here is our original question. We found all these points. We found this x-intercept is at 1 and that one is at 3e, right? Equation of our line L is equation of the line L, let me write down here, was what? So equation of the line was x plus 2y equals to 3e, right? So we get x plus 2y equals to 3e. So that is the equation of line. Now we need to find the area of this portion. How do we do that? Well, one of the way could be that we can just drop a perpendicular from here, right? So if I drop the perpendicular, I can say that this is part of two areas. One is area of the triangle. So let's call this point as Q, right? And let's call this point as R, not R. This is something else, this is a T. Okay, so one is a triangle, the other one is a curve. So area of the curve we can find using integration, and area of this triangle we can do half base into height, correct? So we know E means this side up to here is E. So we have 3E here, so this should be 2E. Is that clear to you? As far as R is this height is concerned, it is also E, correct? So from here we can find area of the triangle. So let's find area of triangle. Which is PQT for us. Okay, so this area is half of base times height, which is half of base is 2e, right? 2e, and the height is e, right? So 2 cancel, we get e square. So we get the area of the triangle, which is half of base, which is 2e, times height, which is e, correct? Now we need to find the area of the curve, which is between x equals to 1 and x equals to e, right? Between these two portions, correct? So now we need to find area of the curve. Let me write down here. So let's calculate the area under this curve. So which basically will be integral from 1 to e, right? So from 1 to e under the curve C, whose equation is x ln x, right? So x ln x dx. So we need to figure out this area. Now we can do this using partial fractions. So we'll use that formula, integration by parts. So we'll actually find this integral by the formula for integral by parts, which is, let me write down the formula in a different ink. So what we have basically is that if we have, let me write the formula here. So the integral of u dv can be written as uv minus integral of v dv, correct? That is how we figure it out. So we need to only identify what to take as u and what to take as dv. So let's take u as equal to ln x. In that case, du will be 1 over x, and let dv be equal to x. So v is the integral of this, which is, well, we should write dx here, 1 over x dx, right? As far as dv is x, so v will be x squared over 2. Right? So that is what it is. So using this formula, this integral will be equal to what? So the integral of from 1 to e for x ln x dx will be equal to product of u and v, which is x squared over 2 ln x, minus integral of these two, v du, right? That's what it is. So it is x squared over 2 times 1 over x dx. And we have the limit 1 to e, correct? So that is what it is. Now, let's simplify this. Well, here x and x will cancel. Let's do this, kind of cancel this portion. So we have x over 2. So we can write down the integral. So we get this as x squared by 2 ln x minus, so here we get x squared by 4, right? 1 to e, correct? Now let's find the area. Substituting e, we get ln e is 1, so we get e squared by 2. Here we get minus e squared by 4, and then we take away, substitute 1 here. So let me write in brackets. So minus 1, that becomes 0, right? And this becomes minus 1 over 4, correct? Minus 1 over 4. So that gives you e squared by 4, and this becomes plus 1 over 4. So we get this area. So the area for the curved portion here, which is, let me shade it in a different color, is this much. Clear? Now we need to find the total area. So let me write the total area here. So we get total area will be equal to sum of these two, right? So which is e squared, the triangle area, plus this one, which is e squared by 4 plus 1 over 4, right? So that gives us 5 over 4 e squared plus 1 over 4. Clear? So now that is how we find the area. Now the question actually was here, show that the exact area R is a e squared plus b, where a and b are rational numbers to be found. So when you compare here, we get a as equal to 5 over 4 and b is equal to 1 over 4. Is that clear to you? Correct? So that is how you're going to answer this question. So I hope you understand all these steps. This was a very beautiful question, extremely important to understand. So what we did was, we first found the equation of the normal, right? Then we found the intercepts for both the curve and the normal. So that defined our area. And then we used integration to find area under the curve from 1 to this portion E. And area of triangle formula we used, half base into height. So that was fast. Adding them up, we did get an expression which was expected, which was kind of a squared plus b. Comparing the coefficients, we got the value of a as 5 over 4 and b as 1 over 4. Perfect. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. And in case you have any doubts, you can always communicate with me on the email address given. Thanks for your time and all the best.